again, today I'm just going to go over the filtering and the sorting using dictionaries. It's probably going to be pretty quick, and then I'm going to talk about where I'm going with this because we are going someplace towards the iOS world. Right now it's just a Swift script. So I'm going to go through it again. So you go to File, New, Project, and if you're uncomfortable, you can like turn your chair and stuff. Okay. And so you. Oh, is it? I don't think this TV turns.
No.
It definitely does not.
Oh, that's right. We were going to move the table. We forgot.
We can move the table. You guys want to move the table?
Move the table.
It's like really like far away from you guys. Can you guys see it? I'll make the text big, I guess. Too much work. All right, so
I can probably see it, but I can make it work.
Yeah, I'll just start a File, New, Project, and go to Mac OS Command Line Tool, and save it to my desktop. And so we have an array of students, and before we were kind of just doing for loops, and we were doing looping with a lot of looping. Did anyone solve their homework assignment using dictionaries or sets or anything? You did? Okay, cool. So just to recap, I have an array of students, and each student has committed some sort of assignment and has gotten a grade on it. And so my task was to take out the duplicates and sort the students by order of highest average grade. And if there's a tie, sort the tie by last name first. And so this is done pretty quickly with dictionaries. I believe I showed this to you guys last time. You can initialize a dictionary using a collection. Student is a collection. Students is an array, and that's a collection. And you can group them by a certain element of that collection. And I chose to do it by ID, which is this thing right here. And so I now have a dictionary, which is a key value pairs, unordered. So let me just run this program. Okay, so what this has done, I wish I could draw on a whiteboard somewhere. Oh my god, that's awesome. I could like throw it on the table. It's a little...
Is it possible we can put it on this table to raise it up?
I mean, we could. I would just need to like record myself a little bit. Maybe I'll do that. This is gonna feel kind of funny, but okay. I'm not gonna do that. I'm just gonna show you what it's going on here. So this unique students dictionary has 5 key value pairs, and so it originally started with 6 elements in the array, so 6 students in that array. And this grouping literally did the filtering for me. So now I have 5 students, and so I should only have one instance of, I guess the duplicate was Lynn, so this one right here. And that was due to the ID of being ABC. And so if I kind of like check out these values, ABC is only in this dictionary as a key once, and if you check out the values, it should have the Lynn Winters as that. So I've already filtered out the unique students using one line of code, as opposed to the I think it was like 20 some odd lines of code to do the double for loop. And then after that, I turned it into an array. So this, I basically let the dictionary do the work of filtering out the uniqueness for me. Actually, oh my gosh, I lied. There's actually two Lynn Winters for that particular key. So if I do unique students dict, and I print out the key of ABC, that was the student's ID, I should get two values. So I actually got two elements here. I'll make this bigger. So in this dictionary, I actually still do have the 6 students in the dictionary. It's just that for that one key, there's two copies of it. And so what I'm doing on the very next few lines is I'm iterating over the keys, and the keys would be the IDs. And I'm literally using something called a map function, and this is where a whiteboard would be useful. And I feel bad for people who watch this again and aren't in class, but I'm going to go ahead and do it anyways. I don't know if we'll get in trouble.
Well, I need to get it.
I think they would have put don't remove.
Is it pretty much?
Napkins. Take a while to erase with this little thing. Can't go erase it, Charlie.
So I'll find some reading materials on mapping.
I love this blank up
Oh man.
Teamwork.
Okay. Mapping is something you can do on, I believe, a collection. So I think you can do it on a dictionary too. Don't know how that works, but we're just going to talk about arrays. So let's say we have an array of integers. And this array has values of so I can map this. This is an array of integers. I can map this to a brand new array of strings, literally just by like kind of converting them. So I could do let integers equal this array, and then I can just call integers dot map. And what you do in the mapping functionality is you say, okay, all I want to do is convert this array of integers into a new data type. So again, arrays can only have one data type. They can't have integers, strings, and a bunch of different data types. It can only have one. So when you map it, you have to say which new data type you want. So I want to do strings. So I'd write some logic, and output would be an array of strings. So on and so forth, all the way down to 10. And the mapping would be exactly. This first element goes straight to this one. This next element goes straight to this one, all the way down to 10. That's mapping. Does anyone have questions on that? Okay, and so a flat map, which has actually been renamed to compact map in Swift 4, what this does is, let's say there's a condition that you want to implement for this array that you're going to map to. So let's say we only want to take the even numbers. So in this compact map, you would do something where you would say something like, I want to map for this element. So the syntax here is like let, and then you can name this integer, and so I'm just going to call it number. That goes into this function. So I'm grabbing onto this constant, and all I'm going to do is say if the number, dot is even or something like that, then I'm going to return the number, or like whatever I want to, like the new type. So this would actually be a string, and you would enter in the number. And so what this method is doing is it's converting the number into a string if it's even, else I'm going to return nil. And what this is going to end up doing is on our new array, we're only going to get the numbers 2, 4, and so on, all the way down to 10. So compact map is going to take care of these nils. So it'll literally just take out any of the nils that you are going to have. So that's enough for now. Does anyone have any questions on compact map? Okay. So in this example, I'm using compact map here, and I'm iterating over an array of keys, which is an array of strings. And so I'm mapping an array of strings to an array of students. This is a unique students is going to have a data type of students. And all I'm going to do is as I'm iterating over it, if I encounter, a key value pair where the value has 2 elements, I'm just going to take the top one. So this will take the top one, and this one will be discarded. And so my new array is going to have just the unique ones. So unique students now has 5 values because, does everyone understand that? Do I need to draw or anything? Okay. So now I have, that's how, that's one way you can basically use a dictionary to basically place things into buckets. That's kind of how I visualize it, is for each key, that's a bucket. And so I'm throwing any copies into, each bucket. So in this particular case, there is 2 students with the ID ABC, and so my bucket was ABC, and there was 2 elements in there. And after I put everything in buckets, I went through each bucket and just took one item out of it, and that will give me the array of unique students. The other way to do this is by using a set. The disadvantage of using a set is you can't really say there was a condition you wanted to have. Let's say you wanted to have a condition where you wanted to have the student to have the highest grade. So maybe your database has every single record of each student and every single record of like an assignment. And let's say, like, for instance, you turned in an assignment on Canvas and you accidentally didn't enter any of the questions or any of the answers, and so you got like a value of 0 for your grade, and you wanted to resubmit it. That's when you would have like a duplicate entry, particularly like, for instance, here. And so let's say I wanted to be nice and only take the one that has the highest grade. So in this condition right here, instead of taking the first one, what I could do is grade dots average. So this should be an array of students. And so what I would want to do is, so right now, let me create a new variable. This what I need to do is return the student that has the highest average grade here. And so I would have to do students dot some sort of like max
So this if statement then says if age is less than 12 and the age of 5 less.
This probably isn't the right syntax, but just trying to make a point. But the advantage of being able to use a dictionary in this particular instance is to again add a condition to base which one you want to pick. So again, if this one, Lynn had her grades for the first one were like 0, and then she did super well on the second one, I would want to take this one, right? To be fair, and this is just the wrong syntax, but it would look something like that. I'm going to go back a little bit. So anyways, that's an advantage to using a dictionary. The other way to do it is using this thing called a set. And what a set is, it's an ordered collection of unique values. And the way that they are made unique is by this protocol called hashable. And what ends up happening is this data structure ends up getting hashed into, like, basically it gets encoded to, I believe it's bytes, and that's how it's able to run so fast. And so hashable is a protocol. Let's just take a look at it real quick. And it is a protocol that also adheres to equatable. So that's like something that you can use to compare two data structures, essentially. And it also has this property called the hash value. And so the hash values are they're basically an integer, which we're going to use to basically hash the data. And so all you have to do is adhere to this thing. And so you would add this to your struct. If I didn't have it, I would get a compilation error that says the student doesn't conform to protocol because I don't have this hash value. And so about this hash value, what you want it to be is you want it to be one way to kind of like identify the student and some way to uniquely identify that student. So in this case, I already know that ID is kind of unique. So all I'm doing is returning ID dot hash value is kind of already on a string. So it actually knows how to just do that. Swift is smart enough to know that. The other part of this hashable protocol is back here. There's this thing called equatable, which is another protocol. And for your reading assignment, you're going to read about functions and protocols, which are super important. And then the other part of your assignment is there's a really, really good. Has anyone heard of Ray Wenderlich? He was a developer out in California. Started his own website for like teaching purposes, and he ended up being the first one who like wrote all these blogs. And then he hired more people, and now he has like a huge team that their whole purpose is to write blogs and videos, and they're really, really good, and they're all based on iOS, and they're being updated. So yeah, they have a great tutorial on protocols, and I will send you that, guys, for homework. So this protocol equatable is a way to equate two student objects. And so the way you read this is this is the same thing as if you were doing student equals student. And so the parameters are left-hand side student, right-hand side student. And all I'm doing to equate them is I'm going to compare the IDs. You could do more things, but in this particular instance, the ID is enough to uniquely identify that student. So as long as you adhere to hashable and equatable, which are these two methods, and this guy right here, all you have to do is call let unique students is equal to the set of the students. And so the set right here literally will take out any unique. It guarantees unique students. So if you have 20,000 students, you have one line of code to completely filter out all the uh, duplicates. That's the power of set. It's super. I believe it's really really fast. We talked about optimization because before we were for looping twice, and that is not very efficient. And so this is not only efficient, but it saves you a bunch of like boilerplate code of multiple for loops into just one line of code. The other thing, so those are the two ways to filter out duplicates. That was just purely for duplicates, either using a dictionary or a set. Does anyone have any questions on that? Okay. The next thing would be to sort the students, and I believe I showed this to you guys towards the end of the class. On these arrays, that you have these built-in functions from Swift. Whenever I force click into a method or a property like this, you can see where the library it's actually coming from. So it's coming from Swift. It is coming from collection, and of those collection, we're looking at array. And so these are a bunch of methods that you can use. So there's like sorting. You can removing like the last one. Reduce is another really cool method. The compact map I went over right here. So a bunch of useful methods that if I find any good reading materials, I'll send those to you guys your way. But it's all about taking arrays and filtering them, sorting them, stuff like that. It even has a filter method, which is actually, I guess, a third way of filtering the students. And so all I did was I just used the sorted by, and it takes in a condition. And so these $0 and $1s, it's the same thing as this type of notation, where it's a function that takes in two parameters. You have the left-hand side, right-hand side. It's just a shorthand notation of doing it. And so it's saying compare the left student. So what it's doing is it's iterating over the array. And so it's taking, like, let's say it's iterating over numbers 1 through 10. It'll take the number 1 and number 2, compare them to, and so the left hand in that case would be 1, right hand would be 2. And so all it's doing is it's comparing the average grade here. The difficult part that was really, really hard about this sort of thing was the average grade was not given to you. I did that on purpose. The average grade, this was the array of students. And on these arrays, there was also another array embedded in those arrays, an array of assignments. And so you had to calculate the average grade in some fashion. I haven't quite gotten a chance to look at everybody's solution on doing so, but in class what I did was I calculated the average grade for each student and then saved it to the struct. In this particular instance, I did not do that. I used something that is called a calculated variable. It is very, very similar to, it is actually the same thing as a function, which you guys will learn in your reading assignment, but here's an example of one. These are all, these things right here, these are all constants. You can also have variables. Let's say they had absences, and let's just say it's an array of like true or false, like they're here or not. And you can like update this array because I'm creating it as a variable, but you'll have to set it each and every time. If you wanted to change it, you would do absences dot append true or, like, as you want to grow that array. The other thing you can do instead of like holding on to a property is you can have a calculated property. And so all I'm doing here is for each student, I'm taking the assignments and I'm using the same mapping functionality that I had there, and I'm mapping it to a grade. So this is really one big line, but let me break it out. This is how I would write it because I'm used to seeing maps and reduces embedded into each other. But what this is doing is I'm creating an array of grades. for the student. And so this is assignments.map, and it's going to return .grade. And so what I'm doing is I'm grabbing all the assignments, which is an array that's sitting right here, and all I'm doing is I'm converting it from an array of assignments to an array of what is this? Integers. And so the grades right here is now an array of integers, converted from assignments to integers. And after that, what I did is I used this method called reduce. Reduce is it's basically a replacement for a for loop. So in the solution that I gave for when I did this the last week, I did a for loop within a for loop, and I created a variable, and I named it like sum. And so as I was looping through the for loop, I was adding to that sum. So I was adding 8 to it, and then I was adding 9 to it, and that was the sum. And I was mutating that variable. What this does is the exact same thing. This reduce, this is the initial property, or this is the initial variable, and it's 0. So I'm saying, okay, I'm going to start at 0, and from here I'm going to add the grades together. Wow, this is really short syntax. So what it's doing is this is an array of grades, and so for instance on this first one, for the first student, it would be something like this: 8 and 9. And what this is doing is it's iterating over this array, and it's adding them together. So it's starting at 0, and when it hits the first element, it's going to add 8. So now we're at 8, and then it's going to add 9 to that 8, which is 17. And so now we have a sum. And again, I can take this out, so it's not like just one huge line. And I'll say let sum is equal to this. And so now that we have the sum of the grades, you have to divide by the number of assignments there were. And so that's all this is doing. And it's returning it as a double. And so this is one calculated variable instead of calculating it each time and then setting it on the struct. Each time average grade gets called, it's going to run this this calculated variable. So for instance, down here, anytime it's going to hit this average grade, it's going to go into that calculated bar. So let me run this one more time just to kind of show you. And I don't really, the advantage of doing this, calculating on the fly, is you didn't have to calculate for the entire data structure, mutate to the data structure, and then loop through it again. It literally is going to sort, and the average grade is going to be calculated on the fly. So I'll run this, and this is going to be kind of hard to step into. Oh, there we go. It hit average grade. One thing when you're, I'll go through some of these debugging tricks that I use. Anytime I see new code, I immediately just throw a breakpoint in there, run the program. And so this is a breakpoint. And so when I run the program, if this piece of code gets called, it's going to stop right here. And so what's really nice about this is you can start stepping into these functions. And so that's what I did. I was sitting right here on this breakpoint, and I clicked this little button that says step into, and I stepped into the average grade. So debugging, this is like during runtime. This isn't compile time anymore. The program is running. I've just paused the program. I've taken a snapshot of what's happened, and that's basically what's happening here. Is the program is running right now. I just paused it. And so we're literally on this line of code right here. The other nice thing about this is over here on the left-hand side, you can take a look at the snapshot of your program. You have the CPU usage right now. It's very, very low. It's actually 0%. A lot of times, what you can do if you're, you see Facebook or something loading and it's taking a very long time, when you're debugging it, you can see how much CPU usage you're actually using. Memory, same thing. If the memory of the memory footprint of your app is just like huge, you're going to be in this red zone, and then you're going to have to figure out, kind of why is this happening. Could be the algorithm is just way too complicated, and there might be a way for you to trim down the basically the logarithmic portion of that algorithm. Moving forward down, you can see these. This is the thread, and so one of the things about mobile development and even web development is you can have multiple threads going. So when your phone is on, there's the processors can. It's not like they can only do one thing at a time. If they could only do one thing at a time, your phones would be really, really slow. And so there's these things called threads that your processor can kind of like use to run different programs. And so right now we're just on the main thread, but on your programs, when you run them, you're going to see a ton of threads, up to maybe 200 at a time. So right now, if you look at thread, can I zoom in a little bit? That did not work. Sorry. But anyways, we're paused on this program, and we're stuck on this first like line of code. If I wanted to see where it was called from, I can just click down, and it was called from here. So remember, I had the breakpoint here, stepped into it, and then I went up. This is extremely helpful for iOS applications that have tons and tons of files. You're literally going to see a huge stack trace. The other thing that's very useful about this is when your app crashes, your apps are going to crash in your users' hands. They're not going to crash as a web app, like on your server and you can log it. They're literally going to crash on your users' phones. And so there's a bunch of systems that can take your crash logs and post them to you, so you can view everybody's crash logs, kind of keep track of all these crashes that you maybe are going to see. And what you'll see is the stack trace. And so you'll see where in your program your app actually failed. And what you can do with those stack traces is you start at the top, at the 0, and you just follow it back. And so this was very, very helpful for instances where you crash, and you can be like, oh, okay, this variable was wrong at this point. And you can literally see your errors. Most apps crash because you did something wrong, and you can fix it using the stack trace. So on the fly, as this program is running, it's calculating the average grade, and it's sorting due to it. So if I kind of set a breakpoint here instead of down here, it's going to get called another time, another time, another time, a whole bunch of different times, because it's basically iterating over that array and calculating the average grade. And so my sort method ended up being just literally one line of code. Does anyone have any questions on that? Oh. Okie dokie.
You see the one line of code in the struct method that you wrote down? You see it back in one line?
Oh, sure. It's just that. Okay. So what I wanted to show you guys, and I haven't posted it yet, I'm kind of lagging behind a little bit. We are going to build something that's very similar to like when you go to eBay or like Amazon and you go to like their webpage and you have a search icon. So we're gonna build something that's similar to it, but it's gonna be for cars. We're gonna make an auto trader app. So it's gonna have. I've already got the data for you guys, but let me post an image of something I kind of thought of. But yeah, it's going to be similar to just like a landing page, and it's going to have, I think I have like 100,000 cars in the data that you guys are going to filter and sort through. So on an iPhone screen, there's no way you can see 100,000 pieces of data on here. You may be able to see, like, even on Slack, I'm looking at 3 different, text messages. One was from Sarah, one was from Amanda, and then the one from myself. So you have very limited real estate on an iPhone as opposed to a web page. So it's going to be very, very useful for you to add filtering and sorting onto your views. And so what we're going to end up building is this is going to be something that you can scroll, like a table view. It's going to have an image of the cars, make, model, year, color. And so instead of literally scrolling on the phone for looking through something like 10,000 pieces of data, we're gonna add some sort items. So you're gonna sort. You can only choose one of these 2. So price, lowest to highest, highest to lowest. You can only choose one of those 2. That's kind of why I have the check mark. And we're gonna build out these views. And so you can sort the model alphabetically, sort the year, newest to oldest. So if I was looking for, the newest car at the lowest price, and I wanted to sort it that way, that'll do the sorting. The other thing we're going to do is filter it. So if I'm looking for a car from like 2000 to 2007, that filter should be filtering your 10,000 rays of cars. And the whole point is to get down to hopefully something that's viewable on the phone. So this is kind of where we're going. This is like, you see this all the time in applications, and you're like, oh, it's just becomes something that you're just like so used to that you kind of take it for granted. When you build this, I tried to build it like over the past 2 nights and like confused myself. So we're not going to do this right away because I'm trying to break it down into smaller components, because just tackling this on straight hand is just going to be really, really difficult. So I'm working on just like, maybe we're just going to filter using the first filter and maybe the first sort, and then do that sort of thing. But I'm still kind of working on that. So for now, what we're going to do is just, it's kind of all I have for you guys today. The assignment for next week is going to be reading about functions, protocols. Those are the 2 big things. And then that Ray Wenderlich tutorial. Okay. So I'm going to go over a few of the iOS tutorials that really got me to where I am now. Ray Wenderlich is one of the highest ones on my list. They have amazing books. So this one is literally it's a good hefty tutorial that you're going to go through and code, and we're going to have you in Canvas submit your finished product of this thing right here. So I'll post this in Slack. So that's one, Ray Wenderlich. The other one that I use pretty often is something called NS Hipster.
It's just shorthand. So if you see a variable on the left and a variable on the right, you can just smash those.
The network's going bad, but NS Hipster is another really, really good one. But Ray Wenderlich, I think, really takes the cake. They've just gone off, and their videos are phenomenal. They have courses. If there's anything you really wanted to learn, it is paid. They have a few free ones, so this one's free. But I've paid for it. It's pretty cheap, and it's definitely well worth it because their videos are the guys that they have explaining things. They just explain it so well, and you feel like so happy and stuff. I don't know. It's like really, really good. So if you're looking for some materials outside of Apple, because Apple's documentation doesn't really provide you with a lot of the knowledge that a lot of these developers have, this is a really good tool. So reading assignment, I'll have a quiz on it created hopefully by tomorrow, and then this tutorial, which will probably take you, I don't know, 4 hours or so. So that's pretty much it. I guess we can spend the rest of the time if you have any questions or.
Will you go over when you have a bunch of options in autocomplete, especially with those higher order functions, how to read those?
Okay. Sure. So let me get rid of some of this stuff. So as you're typing, there's your IDE is trying to help you. The IDE being Xcode. So if I were to, this is a dictionary. The first things that it basically says, here is the entire list of things you can do right now. It starts with very, very basic things, and then you'll start to scroll down and you'll see things that are actually more narrowed down towards just dictionaries. And so these are like, as I'm reading this, the left-hand side is what it's returning. If it returns void, it means it doesn't return anything. And so functions. Functions are little pieces of instructions that you can say, let's say I'm baking a cake and I want to create the batter first. You would have a function that says create batter, and it would just create it. And let's say it doesn't actually return the batter, just kind of like leaves it there or something. That's what a function is. You could also return the batter so that you can use it later, but functions have return values. And if they don't, they're marked with void. And so this remove all, if I wanted to completely kill my dictionary, I would use it. And that doesn't return anything. Other than that,
So open up the predictive.
the which one?
Open up the autocomplete for one of those.
Okay.
Just really work with them. So if you scroll down to, let's look at filter or compact map or sort.
Okay.
So when we're looking at this part, inside the parentheses, this is your parameters. This is giving you a clue of what it accepts before you even start, completing the function. It gives you an idea of what it needs and whether you can think about whether you even have it. And then this part here, this is included. This parentheses student throws arrow bool. This is telling you that it's accepting a function. So you can pass in a function in order to tell filter how to do its job. So that's why, when I started writing in Swift, some of this syntax just kind of threw me for a loop, and it took me a while to get used to it. So that's why I wanted to bring it up. But other simpler things will just tell you is included bool,
Another one that's really, really useful on an array is something called first. And so let's say you have an array, again, of students, and you want to grab the first. So an array is, again, it's sorted. So index 0, index 1, 2, and it literally is sorted. So when you say first, it's going to start at index 0 and go through an array, and it'll return the first element in your array that meets the condition. So actually, that says exactly what it says. It says returns the first element of the sequence that satisfies the given predicate. So if you were looking for something in your array and you wanted to find the first student who has the last name of Grant, I could do something like, so I'm saying unique students that first where, and then $ last name is equal to Grant. And so I could save this into a constant. I'll just say Grant. And this is now potentially nil. If you notice here down here, it's got a question mark. One of the really good things you should that helps me is I use this Alt key, and then I tap on it, and it'll give you some information. And it's returning an optional student. We learned optionals back last week, but I'll go over them again. So most of these data types, like string, these are constants that have values, and they absolutely will have values no matter what. There are some instances, not some, there's a bunch of instances where you may want to have it be optional. Is it really optional for the student to have a first name? I'm not really sure. I think most people have first names. Maybe something like middle name. That could be optional. And so what that means is this middle name is, for that property, it's going to be nil. And so this thing is saying, okay, I'll return you the first student who has the last name of Grant, but I can't guarantee you that there is a student with the last name of Grant. So it's returning optional. So again, when you back to functions, if you return, the cake, and the function is supposed to like create the batter, maybe it messes up because the cook is like a noob like me, and I don't make cakes very often. But it would return an optional batter. So like whoever uses that function, they may or may not have the batter to use to make the cake. The other thing is if you tap right on the method itself, and that's not cool. What's going on? So over on the right hand side, there's something, I'm not sure what's going on. It's really useful. Hold on 1 second. I have a compile error, so it's not happy. Oh, this thing. This right-hand side is really, really useful. Most people don't use it, but Apple gives you a ton of like information on how to use Swift, essentially. So this one is just talking about strings. I really want to just show you this guy. So if I do first, and I just hover if I click on first and just it starts blinking there, you can start reading about first. And so this is really, really small text, but if you do it on your own computer, you can kind of read it. It gives you an example. So it's giving you numbers. The numbers are 3, 7, 4, -2, 9, -6, 10, and 1. And this is saying if let first negative. So numbers that first where the number is less than 0, that's how you would figure out whether it was negative. It basically shows you how to use a lot of the more complicated methods. They give some very, very good examples. This one's pretty easy. Just give me the first one where it meets some condition. But that's really helpful. Other than that, you can force click into it, and Xcode will blow up on you a lot, and that's what it looks like when it blows up on you. When you lose your colors, it basically like lost its indexing and just kind of gave up and just gave you nothing. Before that worked really, really well, where you could force click into it and it would take you to the exact method, but it's kind of been broken. Xcode's kind of just been in a broken state for a little bit. I think Xcode 10 is going to be really, really cool. I hope. I just clicked, so if I wanted to know what compact map was, I just click on it. You literally just click on, so dictionary, it tells you about dictionaries. Compact map tells you about that.
You have to have that open first, or will it open?
So this right-hand little button right here will open it for you. And then there's tabs on here. So most of probably what you're looking at is probably this first one, which says File Inspector. This one is, quick help. So those are a bunch of useful tools if you have questions about that kind of stuff. Does anyone have any other kind of like generic questions kind of like that might help you debug or understand things better?
Earlier, when you were talking about the computer variable,
Yeah.
when I was reading about that, you had to put function in front of it. So I never saw where you can actually.
She's talking about the getter and setter.
Well, there was a couple different ways, but
Get set.
there was get set, or there was just you didn't have to get set unless it was without. It was a different struct that you had to pull.
Okay.
But it looked like you could just put a.
Yeah. So this is actually the syntax of creating a calculated variable. You literally just say var thing, and then you give it a type. I don't know, integer.
much easier.
and all you have to do is return like something of that type, and you're good to go. That's a calculated var, which this is a function. The other way to declare this, and it'll actually yell at me if I do this. If I say thing, and functions are they are again pieces of code that you can run to break up your code. They accept parameters, and so that's what these two parentheses indicate. Right now there are no parameters, so there's nothing going in the parentheses. And you have a return type, and the return type is indicated with an arrow. So I'm returning integer in this particular instance, and this does the same thing as the thing above it. And if I try to build, it says invalid redeclaration of thing. These two are synonymous under the covers. They're the exact same thing. One is just a calculated var, and one's a function, but they are the same thing.
But the way you call them would be different.
Yeah, so if I were to call them,
And the way you access it and the way it saves is different.
Right,
So-
the default. Yeah. I get that. That's awesome. Though. That was way much easier. That's way easier than
what you were seeing,
yeah.
what you were seeing was not a calculated var. It was a var, which is different. So let's say the thing is 0. I set it to 0. It is no longer doing a calculation. It is just 0. What you were seeing is, man, I don't even know if I want to show you guys this.
Well,
You can
put function in front of things.
well, there's a getter and setter, and so you can do things on the I kind of think of them as a trigger. So as soon as I were to set thing, like outside of this, let's change it from thing to middle name, or what would be, I don't know.
Age.
Good one. Good one.
Calculate age from the birthday.
Yes.
Okay, so age. So right now I am 30 years old. A year from now I'll be 31. So on the event that I turn 31, an event would be triggered. So you can do something like something called did set, and that is, this piece of functionality will get called whenever the age is set to a different thing other than 30. So this would actually get called. The other things that you can do is if you wanted to do something at the actual event of it getting set, you can say something like this set takes in an implicit new value. So it's actually saying something like this. It's kind of like a function that takes in an implicit parameter. And so this new value is like hidden from you. You can't actually see it. It would be kind of redundant for them to type this out for you. But just know the new value is the new value in this particular instance of setting. So let's say I wanted to do something like happy birthday when I turn 31. You can do a bunch of stuff, in this, code block. The other thing you can do is when I get it, maybe I wanted to lie about my age, so I could return the age, and I could just subtract 10, and I'm 20 years old now. So that's what you were seeing, is these getters and setters when these properties are being accessed.
So sorry to interrupt, but I am heading out. I will see you guys next week.
All right. See you next week.
But again, I'm just showing this to you guys. There's so many better ways to do this sort of thing without using those setters and getters. I started using them when I first started coding, and it just, a lot of bugs can happen because a lot of people miss that sort of thing. So I would just advise to be cautious of using that sort of stuff. Does anyone have any other questions or anything? Anything in the reading material you didn't understand or anything? Okie dokie. All right.
Would you be so kind as to post your code somewhere so we can pull it? And
Oh, sure. Yeah. I'll put it on my personal GitHub for now, but I know they want all the material that I'm creating. They want it on their GitHub. So I just need to figure out how to do it. Their process is like a little complicated. You gotta spin up this like program that like runs. I don't know. I'll put it on my personal GitHub right now. Are you guys familiar with Git at all?
You said you
Sweet.
were recording it?
Oh, I am recording it. I'm going to stop the recording.
So that will be on Slack, or you'll send it to us?